all over the place. I had to re-record this one. All right, in this video, we're going to talk through the last example, example 10. I had to re-record this one. So let's work through the following application of modular arithmetic. So modular arithmetic shows up all over the place in computers, in programming, in understanding how programs are written. And one thing that algorithms are used to do is there's this idea in cybersecurity and in computing called a check digit. And a check digit is basically a way to assess whether a value is sort of what you would expect. So one place that this gets shows up in is in credit cards. So there's one algorithm called the Loon algorithm. You'll see an exercise like this on the homework. And the way that it works is the following. So credit cards, as you may well know, have 16 digits. Now it turns out that the very last digit of this is actually going to be sort of forced based on the preceding 15, and it's going to follow according to a certain algorithm. And now, the way that this is going to work is we're going to start with the second digit from the right, so that's going to be this one right here, and we are going to replace every other digit with its double. So let's just keep track of the things that we're doubling here. So we're going to double that 3, this one, this one, this one, that, and that. In other words, in this particular instance, since it's an even number here, we are doubling the first, third, fifth, and so on and so forth. So we're going to replace all of those with their doubles. So probably the easiest thing for me to do is to just go ahead and write down this number again, just with a little bit more spacing. 7135. I promise this isn't my credit card or anyone's credit card that I know. I just made up these numbers. So let's go ahead and take these things and replace every other number counting from the back. So it's actually going to be here, this, every other number starting from the left, when we're doing it this way, but the Loon algorithm can be used to check other numbers, in which case it works the way described above. So we're going to replace every single number there with its double. So instead of 4, we're going to have 8. Instead of 6, we'll have 12. 7 gets replaced with 14. 3 gets doubled to 6. 2 gets doubled to 4. 6 gets doubled to 12. 3 doubled to 6. And then 3 doubled to 6. So now the next thing we're going to do is we're going to add all of the digits in the newly calculated series here. So I'm going to include all of these numbers. So every even one here is just going to get added to its value. And here's the thing that's slightly confusing, is that when it comes to adding the digits, remember digits, so when I see the number 12, there are 2 digits to 12, the 1 and the 2. So when I'm adding up all of these digits here, I'm going to have 8 plus 4 plus 1 plus 2. So I'm going to count the 1 and the 2 separately here, and then plus the 2 there, plus 1 plus 4, and then plus the 1 here, plus 6, the 5 that's up there, the 4 that's here, the 1 that's up there, still going the 1 and the 2, that's right here, the 4 that's there, and then another 6 here, 7 here, and another 6 here. So we're going to add up all of these values. A little tedious to do so, but we can do it. 12, 13, 15, 17, 18, 22, 23, 29, 34, 38, 39, 40, 42, 46, 52, 59, and then 6 is going to be 65. Okay, so we computed that. Again, for computers, that part, very easy to do. We're going to check this thing. These are now going to get added in mod 10. Now remember, when it comes to doing modular arithmetic, as we've been talking about, all we really need to do is do that addition and then think about the number in mod 10. So now if we do this value, mod 10, remember we can get to that modular result by just subtracting by 10 a number of times to get it to fall within the range from 0 to 9. So 65 mod 10 would end up equaling just 5. And now the check digit here is going to be 10 minus this result. So that number that we just got here, of 5, I'm going to subtract that from 10. That would also be 5. And this thing is going to be my check digit. So if this thing is a valid credit card number, it would mean that the digit C must be 5. So that's one way, by the way, if you ever are typing out your credit card number and before you submit it, or rather as you're trying to submit it, it's saying, hey, that's an invalid credit card number, right? It's not like running your credit limit or anything like that. It's actually checking it against this algorithm. And if it doesn't see that that check digit is exactly what it's supposed to be, then the computer can automatically note, oh, this one's not going to work. There was some sort of input error, because for a credit card to work, it has to follow a particular algorithm. Now, again, the Loon algorithm might not actually apply to your credit card. If you feel like checking this, you can actually double check if your credit card does follow this rule. It may or may not, because different algorithms exist, of course, for different companies, for different programs. A lot of times algorithms are kept secret, right? But this is one way that we can have a sort of built-in error correction to make sure that the number that we're writing down here is the number that we expect. All right, take care, have a great homework section, and that's all we have for this unit.